now we can finally go back to what we were talking about with MetaMask and that decoding the transaction data and all this weird stuff. If we come to a contract address, and this is WETH, this is a contract that wraps native ETH and turns it into an ERC20 token. But if we come to a contract, right, we hit write contract, let's connect to Web3, sure. You don't have to actually do this, just feel free to follow along with me. We're gonna open up our MetaMask. Let's go to Sepolia here, gonna connect here. Okay, cool. And we want to call transfer from, right? And let's just add some stuff in here. Let's do source, address, and this. This is probably won't go through because I don't have any WETH right now, but let's just hit write, right? This transaction's MetaMask is probably gonna be like, hey, this is gonna fail, whatever. Yeah, sure, whatever. But when we get a MetaMask transaction that pops up, if we scroll over to the hex, we scroll down, we can now actually start to understand what is going on here. And this is what we always want to make sure is actually correct when we're working with our MetaMask and when we're dealing with all this. So what we can do is we can actually copy this whole thing and pull up our terminal here. I'm just going to make this nice and big here. What we can do is we can do cast -- help. We hit cast help and we scroll all the way up. There's a command in here called call data decode. Decode ABI encoded input data. So if we do cast -- call data decode like this, we can see we need to pass in a SIG and the call data. So luckily for this transaction, our MetaMask was smart enough to know that we're calling the transfer from function. But sometimes it's actually not going to be smart enough to figure this out. So that's where we are going to need to match what we expect this to be calling to what it's actually calling, right? So first off, we are expecting this to be calling the transfer from function. So I can grab this function selector, which we just learned, come back here. I can do cast sig, and I'll pass in here transfer from the whole function signature, which it takes a address, and a uint 256. So we'll do address 256. And we'll see that this is what the function selector should be. So I can say, okay, great, the two of these match. This is indeed calling the function selector that I want it to call. Okay, awesome. If it doesn't match, what can happen sometimes, again, we can go to something like the SAM CZ Sun signature database or openchain.xyz/signatures, paste this in, hit search, and we can see that there's actually two different functions that have the same signature. One is transfer from, and one is Gasprite bit ether with an int 128. So what's interesting here is you can't have a function with the same function selector. So if I actually went into remix.eth.org, let's actually create a new contract called conflicting.sol, right? And we'll do we'll zoom in here, SPDX license identifier, MIT, contract conflict. I made a function called transfer from with an address, uint 250, or address hi, uint 256, hello, uint 256, sup, public, like this. And then I also have a function with this one, Gasprite bit ether, paste it in here, Gasprite bit ether, int 128, sup, public. And I try to compile this. Guess what's going to happen? Compile. Oh, let's pragma solidity 0.8.18. This should be an address too. And now I try to compile. We scroll down, it'll say function signature hash collision for gas price bit ether. You can't have a contract in Solidity where two functions have the same function selector. So in any case, we could be calling one of these two functions on this is where it's important to actually go through the contract code and say, okay, there could be a couple different function selectors here. Let's make sure it's the one that we expect, right? So in any case, so this is calling this transfer from function. If this contract has a gas price bit ether, it might be calling that. But in any case, we know, so we could go through the code, right? We go through transfer from. Okay, great. There's a transfer from function. That is indeed what we want to call. Function selector is working. Perfect. Okay. So now that we've verified the function selector, we should also verify the rest of this stuff. So now that we know what the function selector is, and we know what the function signature is, we can take this whole hex here and go back into our terminal and use that call data decode. So we can say cast -- call data decode. We can see what we need. We need the SIG and the call data. So I'll hit up. The SIG is going to be transfer from, and it takes an address, and a uint 256, right? We can just double check that. Address, uint 256, sure does. And we can paste in that call data and hit enter, and we can see what this call data stuff is using for input parameters to that function. So it's our address, and then 1000. And then if that's what we expected, so let me reject this for now, go back to write. And if that's what we wanted to call in this function, we would go ahead and put this through. This is especially important when we're using front ends, like for example, if I wanted to use Uniswap, right? Let's go ahead and connect here to MetaMask. Yep, connect, looks good. Go away, go to, let's say if I was on ETH mainnet, I wanted to swap ETH for, so I'm on a testnet here, so obviously nothing's showing up. But when I hit swap, if I was on a real network with real money, what I want to do then is do that same process of going through and checking to make sure that the transaction that it's sending is actually the one that I want it to be sending, right? So if we want to be absolutely sure of what our transactions are doing, we can first check the address. We can take these exact steps to say, I know exactly what function my transaction is calling. So we check the address to make sure that the contract is what we expect it to be. And then we can read the function of that contract that we want. We check the function selector that we're using so that we know that it is indeed the function that we're calling. And then we decode the call data to check the parameters that we're sending. So this is how we can actually make sure our wallets are doing what we expect them to do. And you'd think, hey, Patrick, why doesn't our wallet just do this by default? And I agree, it should. At the moment, there's projects being worked on. One of them is Fire, where they get some of the transactions right, but more wallets are being created right now that actually decode these call data by default. And I hope more of them show up so it's easier to be safe. We've seen people send transactions not checking every detail of the transaction. And sure enough, it was a malicious transaction, right? So you want to make sure you check the details of your transactions, especially when you're sending and working with a lot of money. Whew.